Hello and welcome to another episode of Windows Innovation. Now let's log in and have a look at the system turnables. The configuration for system turnables primarily will look at the proc values, the Cctl proc values, and the kernel loadable modules. Let's open a terminal and take a quick look at the proc file system. Let's log in as root. So now that we're on the proc file system, there are three different components. The PIDs, as we can see, every process has their own PIDs, and the processes are managed by PIDs. Then you will have the different segmentations, the information files like CPU info, partition, or memory info. In our case, we're primarily focusing on the system. Under the system, we have different allocations. For example, for file system, kernel for kernel parameters, net for network parameters, and VM for memory. Let's check the VM parameter. This is primarily used for memory management, and it has a few parameters here. One of the common ones is Swappiness. So the Swappiness parameter is primarily used for measuring the memory pressure across the kernel. As the physical memory runs out, swapping kicks in. This is just an example to figure it out how the swappiness of the system works. So let's look at the value of swappiness. In this case, by default, is 30. But what does this mean, this 30? So there is a value between 0 and 100. So when the value is a 0, the kernel will not swap. When it's 100, then the memory will be very aggressive at swapping. So we can change this by basically using the echo command. So we echo the value from 0 to 100 into the swappiness parameter using a redirect. So basically, by changing these parameters, we are actually making the kernel value to be running on real time. So in this case, let's do, for example, a quick echo of 70, which is a aggressive value or a higher aggressive value than 30. And that will be the new value that the swappiness kernel parameter will take in. Let's put the old parameter back, which is 30. Okay, so the old parameter is back. So each one of these parameters have a different way of configuring the different variables or tunables within the kernel. So let's look at another one. Let's look at the service itself, which is Cctl. Basically, Cctl is just a systemd variant that actually control the tunable values within the kernel system. In this case, using the Cctl values as well as the echo values, those values will only persist until the next reboot. So let's look at the service itself using Cctl status systemd.sysctl. So basically, this will validate if the service is running, if it's enabled, and provide us a actual status of the service as it relates to systemd. So the actual configuration for Cctl is under etc. And the actual name of the file for that tunables is actually um, system.conf. So we can see that cctl.conf is actually a symbolic link to it under etc. Now when we cat the cctl.conf, we actually see multiple folders where the configuration lives itself, right? So in this case, there is a series of different values in which parameters are read. So the documentation you see here, we provide a good overview of how things are read. So in this case, the default settings, user lib cctl.d, custom settings live under etc cctl.d, and then the runtime generator settings are under run.cctl sysctl.d. The user lib is more generic overall. Our own settings will be saved on the etc sysctl.d. Now, there are some variants to that since we can define and we can check on cd user lib sysctl.d. Now we can see there are a few configurations there. Let's check, for instance, 60.lib.vert. Now we can see in this file we see a parameter called fs.aio.max-nr equal some number. The actual parameter is the critical part, and this is a relative file name relative to usrproc.fs.aio-max-nr. So this is correlational to the Swappiness value that I showed you earlier. In this case, it's just 104,576. We can set up these values, and this will kick in with a cctl-p. Now let's look at a different file. For example, cat. Let's look at the next file, which is 50 default.config, for example. And this one has a few different values. But these are the system defaults. They could always be changed and adjusted to improve the stability or performance of the system. Now, we're going to make those changes under cd etc cctl.d. This is where we define our actual custom values. And it's just a symbolic link to etc cctl.conf, right? So it's very important that the values be defined here. So remember the swappiness that we already defined using the echo command. We could also define a static entry here by editing the actual cctl.config or the 99 file. So in this case, let's type swappiness and let's make that equal to 40, for instance, right? Let's save the changes. Now, this means that the next time cctl initializes the configuration, this will be the new value within the kernel runtime. Now, when we save these files, there is a couple of ways to actually make this effective. We could do the echo command like we did before, or we can actually use the cctl binary itself. Now, in this case, we could do a reboot, or we could use the cctl utility. In this case, we don't want to reboot. We will use the cctl utility and tell the runtime environment to apply the new values based on the configuration file that we just edited. In this case, we're just going to type Cctl, and we're going to use the space -p option for actually revalue for configuration file. That's what the -p option means. In this case, we're just going to tell the system that our configuration file is under etc cctl.config as we initially edited it. Okay, so let's type cctl-p and then followed by the actual file that we just edited. Okay, it's giving me an error that I made a typo. Let me go back to the file and take a quick look. I think I forgot to type the bm additional parameter for the file. Yep. So let me make that quick change in there and save it. And then we can actually save the file now after typing bm. And then we could retype and see how the parameter got applied now. And now you can see that the bm swappiness is now equal to 40 instead of 30. So there's an additional parameter that we can use in relation to the utility of cctl, which will give us an overview of all the different parameters within the kernel over tunables. And this will give us all of them. How many are there? We can always grep it or do a word count, and we can see that there are 1,207 parameters, right? There is a large number of parameters, and these are tunables that we can always tune for performance reasons. So cctl, basically, we can always use -a and grep for a specific parameter using the grep I, like Swappiness, and that will give you the actual value. This is all for System Tunables. Thank you for watching, and don't forget to subscribe.